great way to start. If you took the opposite of the square root of 100 or the square root of negative of 100, how many of you think those are the same? Same. Are they? No? How many think they're different? Yeah. So, Avery, how are they different? Exactly. Exactly. One of them is just negative answer, and one of them is what we call complex. And if you were to take your calculators right now, go back to, what's the normal one? Just function mode. Go to function mode, and just try putting in the opposite of the square root of 100. Do you get negative 10? Right? If you did that? Try putting in the square root of negative 100. What do you get? Error, right? This is not negative 10. What this is 10 times the square root of negative 1. And we have a name for that. It's 10 times I. I is the same as the square root of negative 1. It's the way in which we deal with the fact that if we take the square root of a negative number, it's not a real answer. So that brings us to something called the Argand graph. Have you ever heard of that? Would you write A-R-G-A-N-D, Argand graph? All the Argand graph is we have an x-axis and a y-axis, as we always did, but these are the real values, and these have imaginary values in them, meaning this is y times I. Okay, it's numbered like this. 1, 2, I'm going to go 1, 2, 3, and this is I, 2I, 3I. So if we were to graph this thing, negative square root of 100, that's going to be down here somewhere at negative 10. Where would this be? Square root of a negative 100. Which axis would it be on? This y-I axis would be somewhere down here. This would be 10. Actually, it wouldn't be down there. It would be up here, 10I, wouldn't it? This is where the point would be. So on this graph, you can see that these are very different from one another. And we'll explore that a little bit further. But 1, 2, 3, negative 1, negative 2, negative 3. I, 2I, 3I, negative I, negative 2I, negative 3I. All right, so with the complex number, there's properties. All I'm going to do today is tell you that you can add 2I plus 3I. What's that equal to? 5I, yep. You can subtract. You can change this into 2I minus 3I, which is going to be what? Negative I. You can multiply 2 plus, I'm going to use a different color, 2 plus I times 1 plus I. Okay? This will be 2 times 1 is 2. 2 times I is 2I. I'm going to say 2I. And then what is I times 1? I, and then I squared. Now when you add these up, you're going to get 2 plus 2I plus 1 is 3I. What is I squared? What's the square root of negative 1 times the square root of negative 1? What's that? Negative 1. It's not 1 yet. We'd have to go a few more to get that. But this is going to be minus 1. So my multiplying is going to be 2 minus 1 is 1 plus 3I. Boring? A little bit. So let me spice this up a little bit. Take your calculators out. And you have never done this with your calculator, because I don't think teachers have shown you how to do this, but your calculator will actually do this. go to mode and zip down to, we've been playing with a lot of different modes today. I think you want to hit function and then go down to, do you see where it says real A plus BI? A plus BI. When you hit that, enter, what it'll do is when I go second quit, I'm going to be able to multiply things out. I'm going to be able to take 2 plus I, and I think I, isn't it second multiplication? No, that's not it. Where's the I? Second decimal? Second decimal is correct. And then I'm going to multiply it by 1 plus I. And enter. How awesome is that? Isn't that great? Oh, let's see if you can divide. Parenthesis 2 plus I. And we're going to divide by 1 plus I. And let's see what you get. Ooh, 1.5 minus 0.5i. Well, that looks kind of weird. So let's see what's going on. We're going to take 2 plus I divided by 1 plus I. Would you write that down, please? This is the only real tough skill that you're going to learn today. The rest is pretty easy. I'm going to do what Jacob said earlier today. I'm going to multiply by something so that I get rid of this I in the denominator. What's that something I'm going to multiply top and bottom by? 1 minus I. You got it. Because using my skills that I learned about multiplication, this is going to be 1 times 1 is 1. Negative I plus I. And then it'll be I squared times negative 1 minus I squared. Well, that looks horrible. In the top, we already did that, didn't we? 1 plus 3i. I remember doing that. So, what's I minus I, or negative I plus I? What happens to these two i's? They cancel out. And what's I squared? Yeah, negative 1. So this is going to be 1 plus 3i over 1 minus a negative 1. What's that? 2, isn't it? So won't this be 1 over 2 plus 3 over 2i? And is that what the calculator got? (1.5 minus 1.5i). It's not, is it? What did I do? Did I do something? 2 plus I divided by 1 plus I. And we'll have to take a peek at that. All right, so here's what you're going to do. You're going to be given 2 complex numbers, and then you're going to add, divide. This is real easy. This is z is equal to 2 plus 3i. What do you think z complement is going to be? 2 what? 3i minus. That's all you do here. So in this part, you're just going to go z times z complement, 2 plus 3i times 2 minus 3i. That's what this means. And then divide, you want to get that thing out. Don't use your calculators for these. I want you to do these the regular way. So go to the end here. There should be an assignment. Got a good day tomorrow. Oh, you're going to like that. So here are 2 complex numbers. You're going to do each of those. Then you're going to do that for 8. And then these are very, very quick. And these are very quick. This is, I want you to see what you come up with the patterns here. So that's for tomorrow.